Yeah, so we are on day 2 of the chain rule, and this is just a quick summary of what we looked at yesterday. I've given you quite a few practice problems, and I just want to actually use the opportunity to run through a couple of examples first before I let you guys work together in some groups here, okay? So I gave you numbers 2 through 5, which doesn't seem like a lot, but all of those are number 2. So, and I actually whited out some of these, so that's why the letters don't all match up. Okay, so that's why there were 9 of these, so I just gave you 5. All right, but here's the thing, guys. With these, it's going to be very important that you practice and then also check your work. Okay, we have solution manual up here. And also in the back of the textbook that's up here, you can check your answers, all right? But it's going to be very important that you pay very close attention to detail as you're working through these, okay? The more you will pay attention to detail, the less likely you will be to make little mistakes that are going to really throw you off in the future here, okay? So let's just run through a couple of these first of all. Let's go ahead and do G on this one. All right. So G, we have this function 6 over 5x minus 4 quantity squared, and we always identified the outer function and the inner function. Okay. So what is the inner function, or the U? 5x minus 4. Okay, so u prime would be 5. Okay, and then we also identified the outer function, the g of u. What is that in this case?
6 over u to the second power?
Yeah, 6 over u squared, which I'm going to go ahead and rewrite because I need to find g prime of u. How will I rewrite that?
6u to the negative second.
There you go. Whenever you have a fraction like that, rewrite it with the negative exponent. And then now we can find g prime of u. What's g prime of u?
Negative 2u to the negative third.
Okay, 6 times negative 2.
6 times negative 12, u to the minus 2 minus 1 minus 3. Yeah. Here, right?
Is that what you meant? I kind of lost you there halfway through.
I don't know what
That's okay.
6 times negative 2. Negative 12, u to the negative third.
Okay, there you go. Yeah, so this ends up being negative 12, u to the negative third. And if I plug u back in and simplify that negative exponent, I've got a negative 12 over the 5x minus 4 cubed. Okay? So now, if I want to find dy dx, what do I do with this?
Multiply by u prime.
Yeah, I just multiply this by u prime. So I have the negative 12 times the 5x minus 4 cubed times the 5. So it's just a negative 60 over 5x minus 4 cubed. All right? Now, listen, I'm writing down everything. Okay, and if you're not sure what to do with this, you need to make sure that you actually write out this process. Eventually, what we want you to be able to do would be to just rewrite this as 6 times 5x minus 4 to the negative 2, and then just write down the whole thing. Okay? Eventually, this is what I'd like you to be able to do. To say, okay, well that means dy dx is going to be 6 times the negative 2 times 5x minus 4 to the negative third times the derivative of 5x minus 4, which is 5. And then you just simplify that. Okay? Eventually, that's where we want to get with the chain rule. We'll do enough of this that you'll probably get there relatively soon. But again, I'd rather you write more and get it correct than try to write a little bit and mess stuff up. Okay? So just take your time now. You'll get there eventually, to where you'll be able to just write stuff down. But for now, just write out your process and really get used to that. Okay? All right. Now, just a reminder here, what are we trying to do if we're finding the gradient of the tangent? It's the slope, okay? Gradient is slope of the tangent, and that means you're finding the derivative at a point. Okay? Find the derivative at a point. Because remember, the functions that we're getting when we take the derivative, those are functions, but remember what they represent. We can plug in any x value of a point that's on the original function, and our derivative function will tell us what the slope is at that x value. Okay? Or at that point on the graph. Okay? So for example, if we're doing this, and we find dy dx, and then we plug in the 1, you know, if I have 1, that's going to be, the point here is the 0.18 on the graph. So that means whatever I got when I plugged in 1, that would be the slope of this graph at this point. Okay? Just to illustrate that, again, we only have 2 here, so I'm not going to do one of these, but just doing a basic one. Here's our y equals x squared. So I have points like 1, 1, and 2, 4. And I have, let's say, a negative 3, 9. Okay? Well, what is dy dx? 2x. So that means that the slope right here, the slope of this tangent line, is 2 times negative 3, because it's hitting this point where x is negative 3. So the slope there is a negative 6. Okay? The slope right here of this tangent line is 2 times 1, 2. The slope of this tangent line right there is 2 times 2, 4. Okay? So notice that the derivative gives us a function that we can plug different x's into, and that will tell us the slope of the curve at those different points. Okay? So just kind of reviewing that concept, because I don't want you to lose sight of what we're doing here. Okay? And, alright, now, these 2 problems are very good examples of the types of problems that you might have to do on, say, like an IB exam or something like that, okay? You're using the rules, but in kind of a roundabout way, alright? Let's do 4 together, and then you guys can do number 5 in your groups, okay? So it says the gradient function of f of x equals 2x minus b to the a power is f prime of x equals 24x squared minus 24x plus 6. Find the constants a and b. Okay? So they give you a function, but we're not sure what the b and the a are. But we're given f prime. So let's think about this. How would we go about figuring out what a and b are?
System of equations?
Okay.
I think for derivative of f of x, we can go the reverse way by the principle we learned, and therefore get the original function.
Okay, what do you mean go in the reverse?
For example, 24x2, it's the form before derivative would be 8x to the third power, and 24x will be 12x squared. 6 will be 6x.
Do you guys think that's right?
Yeah.
There's probably the last term though.
There might be a last term
Yeah, that's the thing.
that's a constant, okay? Now actually what you're doing right there is kind of intuitively figuring out integration. Okay? And integration actually is kind of intuitive with these polynomials. You think about the power rule and you just do it in backwards and you get the integration rule, okay? Now, you may not figure out all of this, but at least think about this part right here. When I take the derivative, what happens to the power of x? You subtract it by 1, okay? So at the very least, we know that f of x probably has an x cubed, which tells us what about this function? A is 3, okay? A is 3, because I've got to have 2x minus b to be cubed in order to end up with something where I take the derivative and get an x squared. Okay? With polynomials, every time you take the derivative, you lose a power. Okay? So yeah, really good. Now we know A, and since we know A, we can actually expand this out. Okay? Now you can actually do the foiling, or hopefully you remember how to do a binomial expansion. We've got 1, 3, 3, 1. Those are our binomial coefficients from the Pascal's triangle. Okay. We do 2x cubed, 2x squared, 2x to the first, and then the last term doesn't have any 2x's. We do a negative b cubed. We do a negative b squared. We do a negative b to the first, and the first term doesn't have any negative b's. So now notice what we get. We get an 8x cubed. We have a minus 6b x squared. Oh, not 6, 12. 12b x squared. Plus, because the negative is squared, plus 6bx minus b cubed. Okay? Now that right there is still just f of x.
Why is the second one just b in that b squared? Or the third?
Because I lost the square. There you go. Okay? Now, since I know what f of x is in terms of b's, what is f prime of x?
24x squared minus 24 bx
Good.
plus 6b squared.
6b squared. Yeah, notice b is a constant, so you do the 1 from the x, okay, and then plus 0, okay, because the last term is a constant. All right, so I know that this is from above there. I know that this is 24x squared minus 24x plus 6. So what must b equal?
1.
Yeah, the only way I can get that is by multiplying by 1 and 1 squared. You can kind of figure it out logically. If you couldn't, you could always do negative 24b has to equal negative 24. 6b squared has to equal 6. So,
Wait, I'm not following.
okay, so if you look at the terms that are alike, okay, you can either write this as negative, whoop, wrong one, negative 24b has to equal a negative 24. So b must equal 1. That's because we were told the derivative equals this, and it has a minus 24x in there. We found the derivative in terms of b, and that minus 24x corresponds to a minus 24bx. Okay?
Oh, I see.
You could confirm this by saying, okay, well 6b squared has to equal 6, so, you know, b also has to equal 1 there. Okay? Technically speaking, with this one it could be plus or minus, but the minus doesn't work with the first one, so b has to just be positive. Okay? So, take some thinking, take some creativity. Depending on how you think it through, you could maybe go slightly different routes, okay? But what I want you guys to do is take the remainder of our time here, work together on the remainder of these problems, and see what you can do, okay? With these, you just got to practice, 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 okay?